Let's talk about the maximum and minimum of a quadratic function. And let's start with an example. Let's say I have y equals 3x squared plus 5x plus 2. And let's say I'm asked to find the maximum or minimum, and I also want to find the location of that maximum or minimum. I want to know what the x value is at that point. Now, when we talk about a maximum or minimum, we don't really know which one we have initially, right? Like your function could look like this, or it could look like this. If it looks like this first shape, you have a minimum. And if it looks like the second shape, you have a maximum. Essentially, the minimum or maximum is just the y component of the vertex, right? It's the height of the vertex. So if I wanted to figure out what this is, I have a couple different methods I could use. First, I could put it into vertex form, right? So make into vertex form. That's my first option. If I want to do that, well, we just have to complete the square. So let's practice that because we haven't done that in a little while. So you factor a 3 out of the first two terms. You have x squared plus 5 over 3x plus 2. You're going to add and subtract that special number. It's this thing here divided by 2 squared. 5 over 3 divided by 2 is 5 over 6. Square it. You get 25 over 36. And then minus 25 over 36. If you need to review completing the square, I have another video with some examples you can check out. For the next step, we say, okay, 3x squared plus 5 over 3x plus 25 over 36. I'm going to move this negative 25 over 36 to the outside. And because it was on the inside being multiplied by 3, you got to multiply it by 3 when you take it out. So minus 25 over 36 times 3, which becomes negative 25 over 12, and then plus 2. Now the inside part here we can factor, so you have 3x plus 5 over 6 squared. That's factoring a perfect squared trinomial, right? And then on the outside you have minus 25 over 12 plus 2. That 2 can be written as 24 over 12, just so we have a common denominator, and you get negative a 12th. So now that this is in vertex form, I know where the vertex is, right? The vertex is at negative 5 over 6, negative 1 over 12. So then you have to ask yourself, is it a minimum or a maximum? Well, this 3 here is positive, right? The function opens up like this. Therefore, we have a minimum value. So you could say that the minimum is equal to negative a 12th, and it's occurring at x equals negative 5 over 6. That would be your answer. Okay, so that's the first method. Another method would be to put it into factored form, and then after putting it into factored form, you could figure out where the vertex is. So let's put into factored form. And of course, to do this, all you have to do is factor, right? So we have y equals 3x squared plus 5x plus 2. Looks like it's going to be decomposition, right? 3 times 2 is 6, so you want to multiply to 6 and add to 5. So I think 3 and 2. We decompose that middle number, so 3x squared plus 3x plus 2x plus 2. We factor by grouping 3x, x plus 1 plus 2, x plus 1. Y is equal to x plus 1 times 3x plus 2. So now that it's factored, we can determine where the roots are, right? So the roots, you set each of these brackets to 0. X plus 1 equals 0, and 3x plus 2 equals 0, right? Solve for x in each case. X equals negative 1, x equals negative 2/3, right? Bring over the 2, divide by 3. So these are your two roots. Now why is this useful? Well, if you know where the two roots are, you can figure out where the vertex is, because quadratics are symmetrical. So the vertex will be located exactly in the middle of these 2 points. So all you have to do is average these out, right? So negative 1 minus 2/3 divided by 2. We're just trying to find the average of these two. We add them together, divide by 2. Okay, how do we add these? Well, this is the same as negative 3 over 3 minus 2 over 3 all over 2. That's going to become negative 5 over 3 divided by 2, which is the same as negative 5 over 6. That's the same x value, if you recall, that we got using method 1. Now to find the minimum point, right, the y value of the vertex, we just plug that into our original equation. So the original equation being 3x squared plus 5x plus 2, I'm going to plug in this value for x. Just like that. And then we can solve this, and this will give us the y value. Okay, so that's equal to y. So negative 5 over 6 squared, that's 3 times 25 over 36, plus 5 times negative 5, that's going to be negative 25 over 6. So I'll put minus 25 over 6, plus 2. You can use a common denominator here, right? Because 3 and 36, that's going to become 25 over 12. I can make this into over 12, right? Minus 50 over 12. Plus, I can make this over 12, 24 over 12. Add these all together, right? And you're going to get negative 1 over 12. That's your y value, or your minimum, right? So you get the exact same answers for x and y as you got using method 1. Okay, there's also another method, and this one's kind of cool. It's a neat little trick. And this is finding the vertex using the equation x equals negative b over 2a. Negative b and a coming from that standard form. So in our case, we have y equals 3x squared plus 5x plus 2. So 5 is your b, 3 is your a, just like it is when you use the quadratic formula. You plug those values into this equation, and you'll get the x value at the vertex. So let's do that. X is equal to negative 5 over 2 times 3. That's equal to negative 5 over 6. Boom, done. This is easily the quickest method to figure this out. Then you want to figure out what the y value is. Just plug that into your equation the way we just did in the previous example. So I'm not going to do all the work of figuring it out again because we just did it, but you're going to plug it in the exact same way. Like this, and when you calculate it, you're going to get negative 1/12. And that's your minimum value, and that's where it's located. So here we have 3 different methods of achieving the exact same thing. So depending on what you have, it might be quicker to use one method versus another. If it's in vertex form, just pull the answer from the vertex, right? You can see it right in the equation. If you have standard form, use this equation, right? It's pretty quick. If you have factored form, just take the average of the 2 roots, right? And then that's where your vertex is. So depending on what you're given, you have all these methods to choose from, right? One might be quicker than another, depending on the situation.